Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, unique part 3. So let us first read this question, then constraint, then the example which is being given to us. From that we'll do the dry run, and then finally come up with the intuition and then coding part. So let us go ahead for the same. So here, 1 minute. You are given m cross an integer array grid where grid ij could be 1 which represent the starting square, 2 which represent the ending square, and both of them are only one. Means only one is starting, means basically there is one block only which is a starting block and one block only which is the ending block. So that's the thing. And then 0 representing empty square where we can walk over, and -1 representing obstacles that we cannot walk over. So these are the four type of blocks which would be given to us. Now what the question wants us to do is return the number of four directional walks from the starting square to the ending square that walk over every non-obstacle square exactly once. So we are required to return the number of four directional walks, which is from the starting square to the ending square that walk over every non-obstacle square exactly once. Means basically wherever there is no obstacle, there we need to walk and then get all those paths which uh which are there without the obstacles, right? And get all the paths. That's the only thing which we are required to do here. Now, basically, this question is actually a variation of yesterday's question only. Yesterday, we were given with the graph where obstacles were not there, and we were required to return all the paths from the source to target. That was the thing. And here today, we are given with a grid where we are required to check for all the paths. But in this, we are also given with some obstacles. There were no obstacles, right? So it is somehow variation of yesterday's question only. So let us go ahead that how we are required to do this question. Now, first about the constraints. Constraints are as per that thing that we can easily do DFS and backtracking on the same. And today's question is also based on DFS and backtracking only. The way yesterday we were doing DFS and backtracking, like that we only today also we can do DFS and backtracking. So now, let us go ahead first with example. So here, uh, in this example, so 100, this is the starting and this is the ending. So 000, right? And then 0000 is there again 00. Okay, this is the 2, but this is the -1. Means this is the obstacle. Our ending could be at any point. That is not necessary that it would be at the what we say rightmost end point. That is not the necessity. No, here we can go in this direction, we can go in this direction. Means in four direction we can go anywhere. So possible path are 1 and this is the 2. Okay, two paths are there. Okay. So these are the two paths which are there. Now when we are at this point, so it can go in this direction or it can go in this direction. So now possible paths are basically in total means now there are four possible paths. Earlier there were two. Now, if it reaches in this direction, now it can go in this direction and in this direction. So now possible paths are, wait 1 minute. When it starts from this point, then it can go either in this direction or this direction, right? So now when it moves ahead and then it reaches this path, or it can go ahead and go there, but it can't go at this particular point, right? So that's where this path is now obsolete, but it can go in this direction and reach this point. And then when it goes in this direction, then also it can reach this point. And when it goes in this direction, then also it can reach this particular point. So now, as per the explanation, they are saying that there are only two paths, and which they are saying for 00 in the starting point. 1 minute. uh, means the starting point which is there, then 0, 1, that is this point, then 0, 2, then 0, 3, and then they reach here 1, 3, then 1, 2, then 1, 1, then 1, 0, then 2, 0, then 2, 1, and then finally the path where we want to reach. So basically they got here like this, means they directly reach at that path. Now for the other, this one, okay, 2, 0, 2, 1, then it told to go to 1, 1, then it got to 0, 1, then it got to 0, 2, 0, 3, 1, 3, 1, 2, and then this. So basically it got by this direction. That is how it reached the final path. And these two paths which it has reached. But now comes the part. See, in this question is earlier I was thinking that at every point we can add up and we'll get the path. But now the thing is that there would be some path which directly reach that point. Means in the intermediate paths if there are, then we won't be counting that. We are just required to check that at the end at what point it reaches the last path. So that would be our final answer. Means in actual scenario we'll do like this only. Means whatever just forget about this. Means whatever paths are being given to us, right? So the only thing is that at what point we are able to reach this particular. Means either by getting from this point or by getting by this point. Means like this way only it was. Means covering up all the possible. See in this question only it is written. It is written that return the number of four directional walks from the starting point to the ending point that walk over every non-obstacle square exactly once. So basically, they just require that all the non-obstacle blocks which are being given to us, there it has walked only once, and while walking only once, it is required to cover all the obstacle-free paths. So that's why we are required to return those paths which are basically covering all the points. Because you can clearly see that when we were doing this particular, here it is covering all the non-empty, not non-empty, but the non-obstacle paths. And then when it was going like this, here also it was covering all the non-obstacle paths and all are covered. And that's why only two paths are there. So in this context only, we are required to get an answer. Now comes the part that how we will be doing this question. See, it is clearly of doing DFS or BFS over this grid, but now the thing is that we are required to cover up all the non-empty paths, and we don't need to traverse that particular block more than once. So that is also another thing. So these are the two things. And now comes the part that while doing DFS, we are not means going to that particular block once again. So for that part, we will be having a visiting array. Oh, sorry. Yeah, visiting array, or we will be marking that block that we have already visited that. And while backtracking from that path, we will be able to figure out with other possibilities that could be there. So that is the thing. Now comes the part that how you're covering up all the blocks. That is one thing. So in that context, the thing is that while doing DFS on this particular grid, we will be moving ahead and marking previous as -1, moving ahead -1, moving ahead -1, and going in all four directions. Like this way only, we will be able to mark all the -1 until we reach this particular point. So by default, it will be covering up all the means all the non-empty blocks, and then it exactly reaches the target. Then at that point, we will be returning 1 to our answer, and that will be forming the means that will add up to our total number of paths. So this is the thing which we are required to do in this particular question. I hope you somehow got the idea that what exactly we are required to do here. But yeah, so let me show you the code. But before doing coding, just analyze and do by yourself that in actual we are just required to do DFS, mark the previous which we have already visited so that we don't traverse that particular once again because we only want to go there only once. And the and yeah, marking them and only once that was the thing. And further we are just required to add up all the paths. Then we hit the base condition. So here one more thing is there because we are required to go to all the non-empty blocks. So for that also we will be maintaining a separate variable which will help us to know means that will help us to keep the base case that if the number of non-obstacle blocks are now equals to -1 and our source has reached the destination, then surely we have reached the path and that will be adding up to our uh, total number of paths. And that is how we hit the base case and that is how we get our final answer. So this is what we are required to do in our coding part. So now let us go ahead with the coding part for the same. I don't know seriously. This happened to me. Now here, these are the dimension and then direction. Actually, this whole code is not my code. I have taken it from the discuss section. But let me explain you through this code only. So now here we start from this particular. Here m cross n means the dimension of our grid which is there. Then this is the source and destination. Basically how we are doing this code is whatever source and destination coordinates would be there, we are storing them in the form of pair. Means basically xy for the source and xy for the destination. That would be stored in this pair. And then int empty. Basically, empty will be representing all the non-obstacle paths which are still left for traversing. So that's the thing. And then comes the part here we are traversing the grid. And then if it is 0, then we will be incrementing empty. And if it is 1, then it is our source. If it is 2, then that is our destination. So basically, we just require the coordinates and that we are getting here. And we require all the, means basically what is the total number of, what we say, empty blocks that we are storing in this empty. So that's the thing which we are doing here. Now here we are calling our DFS function. First passing the first coordinate means x coordinate of a source, then y coordinate of a source, and then the total number of empty blocks which are there, and then destination which is there, which we got from here, and then finally the grid. Now let us go ahead. So here this is that function we just check for outer boundary condition. This thing we could have written here as well directly, but making a separate function is somehow as per the modular practice is one of the good things. Now here this is the base case. So for base case, if we are left with left equals to -1. That simply represents that now we are not left with any non-empty, basically any empty block. And then this simply represents that the block at which we are there now, that directly correspond to destination. So at that point, we are returning 1, and this 1 would be adding up to the total number of paths. Now this we are marking it as that we have already visited the same, and here it is starting our answer would be 0. Here we are traversing in all 4 directions with the help of the direction array which was there. And here we are just adding up all the possibility. If it is a valid, means it is not out of bound, and if it is not equals to -1, that is, it is either not visited or it is not a obstacle block, then we will be adding up to the answer. And what we are adding up, whatever after doing the DFS over the whole grid, we get there, that we will be adding here. And every time we are decrementing our left by 1, so that when we reach at this point, then it will be returning 1, right? And when it returns 1, then it will add up to this answer. So that's the thing. And at the end, we are required to backtrack to check for all the possibilities. So that's why we are making that particular grid of ij equal to 0 again after traversing in all 4 directions and after having that DFS. And then at the end, we are returning the answer. So this is all what we are required to do in this particular question. Now comes the part for time complexity and space complexity for the same. So here the time complexity is directly order of n into m, that's for sure, because we are traversing this particular grid. But now comes the part for the space complexity. So basically the space complexity is all because of this pair which we are taking and nothing else. That's where the space complexity becomes order of 1 only. So this was all for this particular question. I hope you understand and you were able to relate this question with the previous question which we did just yesterday. So yeah, this was all. And if you still have any doubt in the DFS concept, then you can check out my DFS and backtracking playlist which is there. There I have explained with the recursive tree. So you will be easily able to check out that how in actual backtracking work with the help of that recursive tree explanation. So yeah, this was all. Thank you.